Good Wednesday morning, everybody. Igniters of the future, seeker of things. Welcome to our first session of Wednesday morning, AI in the Age of Social Responsibility. I'm Bill Baer. I'm a product manager for Microsoft Search and AI at Microsoft. I am largely here for humor and to create awkward moments. And joining me this morning is...
Howdy, I'm Jeffrey Snover. I'm a Microsoft Technical Fellow. Last year I gave a talk called Software Development in an Age of Social Responsibility. And when I told my wife I was doing that talk, she said, "What the heck? Why are you wasting anyone's time? No one's going to want to hear that, and what's in your head?" But I thought it was an important message, and it turned out to be one of the most highly rated sessions of last year's Ignite. So I think there's a really important conversation to have. Now, since that time, I've changed roles, and now I'm in the the architect of the intelligence substrate, which is an AI layer within Office 365. And so this year I thought, well, I've been thinking a lot about AI, and so I thought, let's have a revision of that talk. Now, this is what we call the thought leadership track, right? So we're not going to get into heavy AI details, et cetera. We're really going to step back and say, hey, what are the issues here? What are the social issues? What are the ethical issues, et cetera? And to give you a perspective. Now, why is it that you got Jeffrey Snover up here giving that kind of talk? Well, it's interesting to think through, well, what's the difference between an engineer and a software developer and a technical fellow? The answer is, as you grow through your technical career, you are rewarded based upon a different set of things. Originally, it's your ability to design, write code on a schedule, write good quality code, then it's into design, then it's into architecture. But when you get to become a partner, and more of it is about judgment. Okay, judgment. The ability to take a look at the landscape and say, this is important, this isn't important, and to be correct, and correct in a way that has business impact. And when you do that and have a pretty consistent record, that's where you become a partner, individual contributor. But then within partner, there's a number of levels before you get distinguished engineer and then technical fellow. And someone asks, well, what's the difference between those? And the answer is consistent track record and scope of impact, okay? So Microsoft has about 120,000 employees. We've got 10 technical fellows, individual contributor technical fellows. And so basically that's sort of saying I've got a pretty reasonable track record of taking a look at a confusing landscape and saying, hey, I think this is what matters, and having a record of being right. So basically that's sort of what this talk is. As I take a look at the AI world, I see a bunch of like fluff and crap over here and BS here and like, ooh, big scary things there. And so hopefully you're going to hear a perspective that you have not heard elsewhere. This is not a mainstream point of view, but I say that in the context of I've got a reasonable track record of being right, and hopefully I'll keep that up and continue to be a technical fellow versus get fired.
Yeah, so if we just think about what Jeffrey had just said, there was kind of those three levels, from software engineer to partner to technical fellow. So looking at my title, which is Senior Trusted Platform Module, or TPM, obviously I write good code, but I don't exercise good judgment, nor do I have a consistent track record.
I think that might be true. He said he was going to go have a camel burger this evening, so yeah. I can see that at the... All right, so let's start. Satya has been very, hammering on this guy. Right? This guy wrote a paper, and do you remember the year? I think it was in the early 60s.
This 70s? Was the early 60s, 68.
68. So Mark Weiser, and he wrote this thing, and it basically said, machines that fit the human environment, instead of forcing humans to enter theirs, will make using a computer as refreshing as taking a walk in the woods. Now, how many of you spend a day with your computer and go home saying, wow, that was as refreshing as a walk in the woods, right? How about you? At the end of the day, I'm just so frustrated, and my wife's like, what'd you do today? And it's like, I don't even know. My fuses are just burnt. Okay, so this is sort of, bear this in mind. This is an important thought in the overarching narrative of Microsoft as a company. This one thought, okay? So let's talk about it. Now let's step back. Again, overarching narrative of the industry. In 2011, Mark Andreessen wrote a paper called Software Eats the World. I recommend you look it up and you read it. It is a short read, but I will give you the heart of that paper. He basically said there are two phenomena happening. Number one is software is eating traditional businesses. Traditional businesses. Bookstores are being replaced with software, with Amazon. Ads, right? Physical ads in newspapers are being replaced by online ads with Google. Music, right? CDs, vinyl being replaced with Spotify, iTunes, etc. So traditional businesses are being replaced wholesale with software. That's argument number one. Argument number two was, even for cases where it does not replace the product, software composes a larger and larger set of the value chain of the software, of the product. So think about cars, right? Cars will never be replaced with software. I'm here, I need to get there, you need transportation. Okay, so software is never going to replace it. But software comprises more and more and more of the value of a car. Today, a car will range in the software content between 10 million lines of code to 100 million lines of code, depending upon the car and the make and the premiumness, the luxury of the car. Luxury cars have more things. So think navigation systems, control systems, infotainment, etc., extra value-added services provided by the car. So those are basically the two ideas. Either software is going to replace existing products, or software is going to become more and more of the value of a product. Now, he said this and he concluded by saying that companies in every industry need to assume that a software revolution is coming to them. No matter what business you're in, you need to become a software business, right? That's why I'm so passionate about digital transformation. That's why I think everybody, all of you, are here to learn about technology. Now, Andreessen wrote that document in what? 2011. And by 2017, and sorry, my slides are out of date here, but this was a list of companies, the top companies in the world ranked by market capitalization. The highlighted list are those companies whose primary value is driven through software. Primary value. Okay, so in 6 years after he writes this document, more than half of the largest companies in the world are primary software companies. Amazing. But in 2011, this was the list of companies, the largest companies. The highlighted ones are the ones whose value is primarily driven through software. Okay? So 2011, none of the largest companies are software companies. He says software is going to eat the world. 6 years later, the majority of the largest companies are software companies. Now this year that's changed. Finance is now in the ascendancy. Most of the largest companies are banks. I will say nothing more than that. But I tee that up to then say this. AI is eating software. That's right. Okay? AI is finding itself into the nook and cranny of into every nook and cranny of the software landscape, okay? It's being incorporated into existing software. It is replacing existing software or existing features of traditional software, and it is creating new classes of software and new types of software. So if you thought software was eating the world, AI is eating software. This is going to become very, very, very important stuff. Okay, so what? Like, why are we having this conversation? Well, here's the key point. You really need to think about artificial intelligence as software 2.0. Software 2.0. This is not a continuation of the journey of software 1.0. This is something fundamentally new, something fundamentally different. And the key point about that, we have no idea what we're doing. Seriously, it looks like it, but we have no idea what we're doing. And by the way, is that a common view? Do you hear mainstream people like, yeah, we have no idea what we're doing with AI? I'll make the point. I'll be clear. First, you got to step back and talk about software 1.0. So if we're saying this is software 2.0, well, how are we doing on software 1.0? Well, software 1.0 has about a 75-year history, right? Again, you can argue about these things. I got this taxonomy from Wikipedia and then modified it. I thought it was a pretty good thing. So really the beginning of software as we know it was really around 1945 through 1965. Lots of floundering around in that time period, right? Just kind of like the term software engineering, I think, was first introduced in a letter to the ACM by the ACM president in the mid-60s. Now, just to be clear, the ACM in March of 1968 was when, like 20 plus years into this, was when we had the go-to considered harmful document. I don't know if anybody ever read that. I did. Remember, that was like a revolution. Oh, go-tos are bad. Now, having established that one point, and I don't think there's any controversy about it today, it was decades before people actually listened to this and stopped using go-tos. So then there was the era of like 65 through 85, right? This is an era people called the software crisis. Okay, so what had happened was there were a number of spectacular failures in software. Spectacular, just flat out spent lots of money and failed, or burst the budget and burst the schedule. And so there was a strong focus in on, hey, we need to fix this. We need to have architecture. We need to have design. We need to have specialization. How do we hire the people to get the productivity to succeed with these projects, right? And in this time period was when Brooks wrote his famous book, The Mythical Man Month. We're at this point, again, now look at this, you're like 20 plus years in where the guy's starting to say, hey, you know what? You can't throw more people. If a baby takes 9 months to create, you can't have 9 women deliver 9 babies in 1 month. Like, it doesn't work that way, okay? Software takes, and this was like a new revolutionary idea. Again, took decades before people stopped trying to just throw more people at a project to bring in the date. Okay, so pretty rough stuff. Sort of the late 80s was the era of no silver bullet. So again, the software crisis just said, okay, all these things that we've been trying, they're not working. And what they realized was that the maintenance of operations was over twice the cost of the initial development, right? So hey, everybody knows, making a baby, a lot of fun. That starts the process. Then you got the whole lifetime of paying for it. Same thing with software. Same thing with software, like that initial thing. Oh, that's really fun. My friend, you're not done. You have just begun. And so it's like, oh yeah, it's more than just getting this code out. And so there was this like, okay, how do we deal with the whole life cycle of this stuff? So there's this focus in on case tools, discipline, formalism. One of our great engineers, Butler Lamson, got his Turing Award for his work on formalism and having to formalize everything. There's an era of software maturity models and a strong desire to get so you can't code unless you've got a professional degree and a certification. All sorts of stuff like this. Again, Brooks, the genius Brooks, basically said, nope. There is no silver bullet. None of the things you're thinking about here are going to give you what you want, right? And so again, what I'm pointing out here is that software, the ability to develop software, has been a struggle, right? So now we're 3-4 decades in, and we're still floundering around with software 1.0. Now, it is my opinion that things turned around in the 90s, right? My opinion is that the heart of things started a little bit earlier with Larry Constantine and his book Structured Design, where he clearly articulated the concepts of cohesion and coupling and the value of decoupling. Now, those concepts were then married with Tim Berners-Lee's concepts. And what he did was he set up down a set of architectural concepts that allowed Konstantin's notions of cohesion and coupling to be applied at scale. Now, this, I think, was the foundation for modern software, is the foundation for good software, okay? This allowed independent development of components. As you know, on the internet, nobody knows whether you're a dog or not, okay? Which is to say, if I talk to some component, look, what's the difference between a DLL and a microservice? A DLL is in my process, right? My library, it's in my process. Well, then all of a sudden, guess what? We have to agree about memory managers. Well, we have to agree on, we share the same environment, so we have to agree upon the operating system and the version of the operating system and the version of the runtime and typically even the language itself. But if we're talking across a protocol, HTTP, look, all of a sudden you can say, hey, you can use IIS, oh, you can use Nginx, you can use Windows, you can use Linux, you can use C++, you can use C#, you can use Erlang, you can use Nosehair, you can use Snowball, you can use anything. All of a sudden this decoupling allowed progress to be made without breaking things. That was, in my opinion, the fundamental thing that allowed us to make progress. And then, since then, 2000 on, is what I call the era of integration. You won't see this in Wikipedia. Maybe I'll go edit it. This is correct, they're wrong. This is the key essence. It's about iteration. We found as, hey, let's go faster. Let's go faster and faster. Because we can be decoupled, I can change it. Like, hey, you used to talk to me, we agree upon the interface. Now, I'm gonna switch from Linux to Windows or Windows to Linux. I did it in C++. Let me try Ruby on Rails. Let me try Python. Let me try this. Let me try Erlang. Let me try this. Let me try some functional programming. Let me try .NET. Let me try .NET Core. Bum, 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 bum. I can iterate. And so there's this desire to go faster and faster and faster and do work. And that then led to DevOps, right? Anybody follow DevOps? Okay, great. If you go to a DevOps conference, you'll see a lot of focus in on, well, what is DevOps? What is it really? Here, DevOps is simple. DevOps is simple. It's only two things. Number one, do your work in small batches frequently. Number two, stop being a jerk to your coworkers. That's all DevOps is. It's all DevOps is. Seriously. It's the heart of it. So it's this rapid era of iteration that has made such spectacular progress and will continue. We're on solid footing. So what is that? That's like 60 years in, we're finally on solid footing. Yay. Okay, so now we're 75 years in of software 1.0. How are we doing? Awesome? Like got it nailed? Got it nailed? Oh, I got this memo from Bill, 2002. He said, hey, we got a problem. Trustworthy computing. Okay, now we took that very seriously, right? We bet the company on this. Last year, this year, 2019, mid-year annual report, I'll highlight this. Here was the conclusion. The first half of 2019 demonstrated that no environment is immune to cyber attacks. So again, how are we doing on 1.0? So when I say software AI is software 2.0, we have no idea what we're doing. It's in the context of after 75 years of software 1.0. I mean, look at the progress that we made, the things that we stumbled over, and how difficult that journey has been and the state of where we are. Now, the heart of AI, like machine learning, let's go with machine learning. When you write code and something goes wrong, you can know that something's wrong, and you can go back, and with skill, you can find out what went wrong. And with machine learning is you have some model, and you put in some inputs, and you build some model, and then you do some test case. If something goes wrong, one, it's very difficult to know what's right and what's wrong. And two, is if it's wrong, you have no idea why it's wrong. You just don't. And here's what's worse. If it's right, you have no idea why it's right. And I bet you think I'm joking. I'm absolutely not. You drill into it. We have no idea what we're doing, okay? So now this then says that this is a new type of software. I mean, it's hard to overstate how much at the beginning of the beginning of the beginning we are with this AI. Let me just go deep for a second and give you, just to kind of plumb the concept. Just a few years ago, a new model came out about this neural nets, something called an attention mechanism. An attention mechanism. Now, this is, let me give an example of what that translates to. Basically, there used to be a model in AI that said, hey, want to understand natural language processing? Oh, let's take a dictionary and let's understand the definitions of all the words in the dictionary, and then I'll try and apply that to a document. Fail. Right? Oh, well, let's try labeling sentences and then using that to understand documents. Fail. What finally gained traction was this notion, kind of a Wittgensteinian notion of you will know a word by its company, which is to say, hey, we look at a very large corpus of data and see which words are associated with which words, and that'll tell us what the word means, okay, in context. And we got so far with that. And then we made a transformation, huge increase in benefit when we had this idea of an attention transformer. And basically what it said was, instead of just random association of words, words go into sequence. And so I'll have this little thread of context that helps me bind things as part of a sequence. So when I say patriot, what do you think? Oh, patriot, Patrick Henry, Patriot Act, blah, 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 okay? All sorts of associations. But in the sequence, New England patriot, all of a sudden it's like, oh, in that context, now I understand it to be something completely different. Then we added what's called a bidirectional attention mechanism with something called BERT, and that basically says, hey, attention helps me understand things in one direction, but also the opposite direction. So now if I say New England patriot, quarterback, this information flowing back that gives me very clear information about what patriot we're talking about. Of course, we're talking about Tom Brady. So now, interesting thing, why am I bringing this up? This attention mechanism is basically like a new math operand, right? It's like having a calculator that can do plus and minus, and all of a sudden somebody says, oh, look, you can do multiply. Like multiply? Yeah. Like when you want to multiply 5 times 1,000, you don't have to add 5 1,000 times. Now all of a sudden you say 5,000 multiply. It's really on that order of basic stuff. Like it's a new primitive for doing processing of AI. So we really are at the stage where we're designing the operators for the engine of AI. Again, still don't really know how they work, but we find that they're useful. So that kind of just puts things in focus. Now, with that, it's a completely different way of writing software, completely different mechanisms, and we have no idea what we're doing. But let me just give you another example of where we know that there's something there, and I've been working with some of our security researchers to try and get out ahead of this and be proactive. And that's the area of machine learning failures. Now, there are 2 types of machine learning failures. First is unintentional failures. There's an example here where they did a study about trying to find what do you call these, moles, benign versus malignant moles. And it turned out that the model actually predicted whether or not it had reasonable accuracy, this model that they generated. But then what they found out was what it was actually determining was whether or not there was a ruler in the picture. Because anything that was suspected as malign, they had a ruler, and anything that they didn't suspect as malign didn't. So all it was really told was whether or not you had a ruler there. Okay, so did I mention we're at the beginning of the beginning? Then there's something called reward hacking, which says, hey, depending upon how you set up the AI, there was a game that got set up and said, hey, maximize your point count, and another one got set up that says, minimize your lose count, like don't lose. And the don't lose model, basically, the mechanism found a way to pause the game, and therefore it never lost. Okay, so these are unintentional failures, and by the way, there's a gazillion of them. But I want to talk about something different, and this is, you'll understand it and then realize how in trouble we are. And that is intentional failure modes. Okay, so I got this machine learning model, and now there's a bad actor that wants to mess you up. Like, how do you protect yourself? What are the threat vectors? How do you threat model a machine language system? Anybody got an answer?
Introduce bias.
No, but good guess. Too bad, because nobody knows how to do this. We're trying to figure it out. We are going to contribute to this by, we're writing some papers here, trying to introduce the start of the conversation by having a taxonomy of machine learning adversarial attacks. So the first is poisoning attack. We introduced a nice, sweet young lady called Tay. You can have conversations with Tay, social thing. And within 24 hours, she turned into this racist, Nazi, horrible entity. And yes, we were petitioned by some congressional districts to have her run to represent them, but we did the right thing. We declined all those offers and took her off the internet. Don't you wish more of that happened? And what had happened was that people figured out that they could interact with her in a way that changed, that interaction fed the model and updated the model, and that's how she became this racist, horrible person, right? Now, common corruption. Tumblr had introduced machine learning models to get rid of pornography from their threads, right? They're trying to clean up their act. Well, it turned out that the hackers found out that they could just include the most pornographic images you can imagine, and they include this little picture of this funky little owl, and it bypassed all their filters. Like, who was the guy that thought that up, or lady who thought that up? But there it goes, okay? And now, perturbation attacks, right? Like, hey, if you know what they're looking for, you can perturb the system. So some hackers put some labels on the road, and they were able to hack a Tesla to steer into oncoming traffic by just putting 3 sensors on the road, right? So a perturbation attack. Now, a model inversion is the case where you can go and through the proper series of queries against a model, you can invert the model and basically extract private information from the model. Ooh, scary thing. So they were able to extract this image of a person from that system. Then there's model stealing. Hey, you invest a lot of time, a lot of money to create IP on this model, and people have the ability to go and steal the model and use it for their own. That's a threat. And then, of course, there's the attacking the environment. Most people understand that. Hey, there's a bunch of components, software components and libraries, and if I can just get into the supply chain there, they all have vulnerabilities that people can exploit. But how, we're not entirely sure. Okay, lastly, here's a set of image recognition. We've actually gotten very good at image recognition. Everybody knows that, right? Awesome at image recognition? Ish. It's true. But here, took a stop sign and just added, high confidence, like super high confidence. That is a stop sign. Add a little bit of filter. Here we did with one of these filters, but you could flash a light of a particular color, and all of a sudden, it's confidence that it's a stop sign goes down dramatically. So now all of a sudden, you shine a light at a stop sign, and your autonomous vehicle doesn't stop. Well, that's going to be a problem, right? Here we have one is AI. This stealth fighter applied again, simple filter, and now all of a sudden it looks like a sundial. Okay. Did I mention we have no idea what we're doing? So often what I'll say is, has anybody ever heard the story about Chichen Itza? That's that stepped a pyramid in Mexico. And the story is that at a particular, I think it's the summer solstice, stand right here and you look and the sun comes up and hits the top stone, and then a shadow comes down the stairs, and it looks like the snake god, Quetzalcoatl, is either rising up or coming down the stairs, and it's just amazing, right? And a lot of AI reminds me of Chichen Itza, right? On a particular day, if there's no clouds and you stand right here and there's nobody else in that spot, something wonderful can happen. Tomorrow, maybe not. If there's a cloud, maybe not. If some kid sits in there, maybe not.
So a lot of things that what you see, these amazing things in AI, are in fact incredibly fragile and brittle, and right to the next of it, you have masterful, wonderful thing, and then disaster on either side of it, okay? So how do we figure that stuff out? Now, all that said, we're going forward with AI. Comforted? Microsoft, I'm going to articulate Microsoft's approach here, right? We're cognizant of these issues. Number one is we're going to learn from the past and be proactive. Look, we know some of these errors that we've made in Software 1.0. The solutions don't apply, but we know that they're there. We know wherever there's an asset or value, there are going to be bad people trying to attack it. We don't really understand those attack vectors, so we're being proactive about it. That's why I'm working with our security researchers to come up with these taxonomies, right? So we know the class of problems, we don't know the specifics, and we don't know the solutions, but we're being proactive about it. Next, we're establishing standards and practices, and we're engaging the community, engaging the communities. So we're going out there educating the security people to say, hey, there's a problem, a set of problems here. What are you saying? How are you approaching it? There's a set of ethical issues. There's a set of regulatory and even intergovernmental issues, treaties that need to be addressed. We're identifying these and working with the communities to try and be proactive on these. We're not going to get it right. We're not going to figure it out in the next year. We're not going to figure it out in the next 5 years. We're not going to figure it out in the next 10 years, right? But what we are going to do is we're going to iterate, and what Microsoft is best at, we're incapable of sustained error. We will work at it, 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 always looking at it. And we are going to have a point of view. Microsoft, we got a phrase. A point of view is worth 50 IQ points, okay? Here's the reality. With any new technology, it is the innovators that set the path. It's the innovators that set the path. Microsoft is going to be an innovator in AI because we want to set a path. We have a different point of view on AI than everybody else, and this is our point of view. We believe that AI must be ethical, and that it should empower every person and organization to achieve more. Now, that's not the case with everybody. Back to our friend, Mark. Mark said that machines that fit the human environment instead of forcing humans to enter theirs will make using a computer as refreshing as a walk in the woods. What's that mean? In the past, you have had to understand the tools to achieve your objective. We've heard it. We've been to Ignites before. How many of you have told us, hey, Microsoft, sometimes it seems like you're shipping your org chart, and I got to figure out your org chart to get my job done, right? It's true. It's true. You've had to figure out the org chart, the tools, and how the tools get things done to get something done. Going forward, the tools are going to understand you to get your job done, right? We're going to flip that on its head. Our view of AI is AI. AI is all about most of AI. Most of AI is figuring out you in order to achieve an objective, right? Our competitors want to understand you to get you to click on this button. Click on this button because it's going to make them money. Click on this button because it's going to get you to buy something you don't need. Click on this button because it's going to swing an election a way they want it to swing. We are going to try and understand you so that we help you do something. And what is the something we're going to try and help you do? And it is make you successful, make you productive, help you achieve your objectives, help you get more energy and meaning out of your job and your life. That's what I love about Microsoft's play. Bill,
all right,
give us all the details of how we're programizing, making this into a program.
So let's go ahead. We're going to move pretty quickly with about 10 minutes. I thought I'd be the one telling all the jokes at this session, but obviously you had a few tricks up your sleeve I didn't know about. So what's our approach to ethical AI? Basically, it's across 6 core principles that you can see here, which is fairness, reliability, inclusivity, privacy, transparency, and accountability. And really, we believe that the development of AI must be grounded in the creation of some framework. And this is our framework. And let's just dive in and talk about a few of these things. Fairness is important, as Jeffrey mentioned. We need to make sure that AI is fair, that it's programmed to make biases or discriminatory decisions that we have prohibited human beings from making. So we need to understand that. To give you an example here, there was a study that was conducted, and fairness can be really subjective, and it can differ. But there was a study that was conducted in April of 2017 to try to understand, is there gender bias in lending? And this study was conducted over thousands of hours and resulted in hundreds of pages of documents to try to understand whether or not there's bias in lending, gender bias in lending. And they came to the conclusion that there was gender bias in lending. So why is that important? The meta point here isn't that this was a model that was trained to where they were able to understand this. This was pouring through financial documents to understand it. But the important thing is, when you're developing a solution, you need to identify bias in your data sets. You need to understand how it can be introduced into your models, into your solutions. You need to attract a diverse pool of AI talent. If everybody talked and acted like me that was on my team, we're automatically injecting bias into our model because it's going to be representative of my thoughts and my beliefs and my thoughts and my beliefs alone. And that's how you create a dictatorship. And you can very well do so if you have a team that's comprised of everybody that thinks, acts, and believes in the same way that you do. So you need to develop solutions that perform in a fair and equitable manner. On reliability, it also has to be sure that it's reliable and safe. So another example here is there was a solution that was developed that uses drones to identify what could be perceived to be violent behavior. The idea was these drones could monitor large gatherings of individuals. So that could be a sporting event, it could be a protest, it could be the Thanksgiving Day parade, it could be a variety of different things where a large number of people congregate, with the idea that using AI, we can identify postures of individuals in that particular audience that may constitute a threat. However, much like Jeffrey explained through the demonstration of the stop sign or the stealth fighter, which could be an aircraft or it could be a sundial, depending upon the lighting in the situation, very similarly, an individual's clothing could actually influence the decision that that individual was actually a threat. Not necessarily based on their posture, but based on their clothing alone. Or simply based on how that individual moves. A disability may cause somebody to move differently than somebody who doesn't possess that same disability. So there was a certain bias that was introduced through that model, and that comes back to speak to reliability. We need to ensure reliability. So how do we do that? One, gather information related to the adoption of the right AI technologies at the right time, which is super important. But also, does it perform accurately for its designed purpose? So it's easy to create things. Creating things is easy, it's fun, as Jeffrey mentioned, but there's lifelong consequences to creating things. And you need to understand what you're creating, and you need to ensure the accuracy of what you're creating when doing so. And then you need to instrument and measure its reliability. And we're going to talk about that a little bit here in a second. We're going to move a little bit quicker. Inclusivity, which is our third pillar. So this is an example of where we're doing something good with AI, and that's effectively one of the projects we recently announced. We have a great partner who developed AI to help children overcome speech disabilities using cognitive services and using machine learning to help them better articulate and pronounce words properly. So from an inclusivity perspective, you need to do a couple of different things. One, have people with disabilities test your system. So for example, in my particular case, I'm colorblind. It's a perfect test for me. Jeffrey may not be colorblind. So if I'm designing a solution for those who are colorblind, I want my testers to be those individuals who are colorblind. So that's one of the most important things. So you want to respect the full range of human abilities. You also have to recognize exclusion. And part of that is creating those diverse teams, ensuring that your talent pool that's developing your models, that's developing your solutions, is substantially diverse. Not just, okay, well, there's 9 Bills and there's 1 Joe. There needs to be more than that. And then you also need to get feedback from users with disabilities, which is critical to ensuring that. Privacy, here's a really fun one. So this is an example of AI gone bad, but with the intent to be good. So in the early 2000s, there was an economist who worked at Target, who was in marketing. And what they were able to identify is that pregnant women commonly purchase 22 similar items. So what they did is they looked and they identified 22 items that would indicate that somebody is pregnant. So the thought was, let's get in front of this audience. Let's not wait until they have their baby and then start mailing them coupons, right? Let's try to get in front of this audience. So the intent was good from a marketing perspective. We can get in front of people before they have their baby, so we can capture that audience before. And effectively what they did is, using these 22 different products that individuals may purchase, they were able to identify whether somebody was in their first or second trimester. So what they started doing was tracking these purchases and mailing out coupons proactively. And they mailed a set of coupons to a 16-year-old girl in Minnesota who received those coupons in her mailbox. She wasn't the actual recipient, her father was. And the moral of the story here is Target found out that his daughter was pregnant before he did. So of course he went to Target to have words with them as to why his daughter was receiving these coupons for these pregnancy products. And they explained, your daughter's pregnant. She's in her second trimester. Congratulations. But that's one of those examples where you can do something great, but at the same time, you need to think about the end result. So really, designing your system, you want to maintain that integrity of personal data that you're either collecting or processing. And you need to think about those downstream effects as well. In the Target case, it was all top level, this is great, we came up with a great marketing campaign, we're able to target an audience, we're able to deliver value to them prior to our solution before, but at the same time, the downstream effects were an afterthought. So you need to provide individuals as well with privacy choices. There definitely needs to be an opt-in. And you also need to be able to identify those abnormal behaviors as well. So quickly into transparency. From a transparency perspective, this is an example of how Google recently explained how their image classifiers make decisions. So the important thing as well is, as you're designing your solution, be transparent with those that you would deliver to. I'm going to move a little bit quicker because the next one is going to be one of my favorites. But again, simple algorithms for intelligibility, simplifying models through feature selection, right? Improving human comprehension of your model outputs. All of those things lend themselves to that. Now here's one of my favorites from Stanford, and this one's more recent, from 2017. So Stanford invented a thing that they called gaydar. And effectively what this thing was designed to do was identify whether somebody was gay or straight. And they wrote a paper on it, and they came out and said, we're changing the world here. Guess what we've been able to do? With 81% accuracy, we're able to identify whether a man is gay or straight. With 71% accuracy, we're able to identify whether a woman is gay or straight. Now, on the surface, you say, well, that's a pretty good accuracy rate. That seems relatively, that's pretty good. 81%, 71%, their model must work. Well, given that if you think of it on the face of it, it sounds like AI can tell if a man is gay or straight 81% of the time simply by looking at their photo. When you read that title, that's what it sounds like. So it sounds like there's some degree of accuracy, but that's not what the figure means. The AI wasn't 81% correct when showing a set of random images. It was only 81% correct when showing two images, one of a gay man one of a straight man, one of a gay woman, one of a straight woman. So that accuracy wasn't applicable to that scenario at which it was provided a set of random images, right? So if you think about it that way, let me just move back one slide. I mean, the structure of that is 50-50. It was shown 2 images: gay man, gay woman, gay man, straight man, gay woman, straight woman. 81% accuracy. Random, it didn't do so well. So effectively, the structure there is 50%. So 1, understand the ethical guidelines under which your solution is being developed. It's the way you can mitigate that. Ensure that you're operating in accordance with those guidelines at the same time. And then lastly, understand, do I need to deliver technical support as a result of this? Don't just turn these things loose. And that was an example of Stanford's. And as I mentioned, we're going to move pretty fast because we want to jump into a couple of demos to show you just a few ways that we apply AI from a productivity perspective. We've got about 30 seconds, so we're going to do this super fast. So one of my favorites here, and I'm going to ask Jeffrey to help me with this, is at Microsoft we have a number of projects that we call our Turing projects. And Turing is all about semantic understanding, machine reading comprehension, and natural language understanding. So one of the places that we're applying Turing is across a number of our different canvases, whether that is searching the web, searching your intranet, searching within a document, semantic search scenarios. So these are always really fun. To give you an example of how it works, I can ask natural language question, and our engine will parse it. So what's the dollar match for volunteer hours? And here, I can get an intranet result. So it correctly parsed my question, and it found the most relevant passage from the most relevant document. But then, since this query is a question, it's using machine reading comprehension to extract the right paragraph from the document to respond to that question that I asked of the system. In this particular case, $25 an hour. There's a couple of things I could do too. So maybe Bill doesn't always say dollar, maybe I say monetary. So I can say, what's the monetary match for volunteer hours? As you can see, I get that same result. Even though monetary doesn't appear anywhere in the source document, semantic understanding tells us that we're looking for dollar amount. Now, Jeffrey speaks completely different than I do.
Yeah, this is a great example of how we, in the past, you had to search for the terms that were in the documents, right? You had to find exactly if it wasn't right. But what we're trying to do is we want to understand you, and then you bring the results to you. So imagine I said, well, yeah, I don't talk like that. What if I said something like, does the company match my volunteer hours with money? Nope. And I got it wrong. Did I do it wrong? Oh. Demos. There you go. Anyway, you get the point. So we're here to try and understand you versus having to make you understand us.
So this worked a minute ago, but let's go ahead and switch gears real quick.
Did I mention we're at the beginning of the beginning?
Yeah. So one of my favorite things, and I appreciate those of you that are actually staying to see this one, is I'm going to go ahead and draft a quick email. So how many of you have an executive admin? So, all of us can't be fellows. So, how many of you would want an executive admin on a day-to-day basis?
Oh, they're wonderful. You definitely want one. Seriously.
I know some of you are just tired. I bet you, all of you in your head wanted to raise your hand and say, I would love to have somebody help me manage my day, manage my calendar. How many people like looking at FreeBusy, trying to schedule a meeting? Yeah, not many of you.
Couple.
Looking at FreeBusy, and then you find the right time slot, but you can't find the right room. What if we simplified that for you? This is another way where we're using AI. So here's a great example. So I'm just going to draft a quick mail to Jeffrey here. And what I'm going to do is say, let's meet to discuss why the demo failed. So we'll just call it that. So what I can do is say,
It's AI, we have no idea.
so one of the things I can do is I can either @mention Cortana, or, bear with my typing, I can email Cortana and say, Cortana, can you find time next week for Jeffrey and I to meet online for 60 minutes? And I can just send that off. And here in a few moments, Cortana's going to go out and it's going to broker this meeting request on my behalf. It's going to find the right time slot, and it's going to work with Jeffrey to find the right time on Jeffrey's calendar. It's going to come back with proposals. It's going to schedule the meeting, and it's going to add a Teams invite, and all I have to do is click on it. If I need to reschedule it, I can just go back to Cortana and ask for something different. Perhaps I want to ask for a room now because we're both going to be back in the Seattle area. So what'll happen here after a while, there's a little bit of lag while Cortana brokers this. What we'll get is a meeting request. So Cortana has received my request and is going to go ahead and start working on scheduling this meeting. And then separately, what'll happen here in another moment is Cortana's going to come back with a number of proposals. If Cortana can't find the right time, Cortana's going to make some proposals. So as you can see here, that was super simple. I now have an executive admin. So effectively what we've been able to do is just democratize meeting management via AI. And this is probably one of my favorite features. So as you can see here, Cortana went out and said we couldn't really find a time, but you appear to be tentative here on Friday, or should I try to find something starting on Tuesday? So as you can see, I can go back, simply respond to Cortana and say, yes, Tuesday the 26th is great, let's go ahead and use that. So I can have a nice little natural language conversation with my own personal assistant. An awesome way to do that. So with that said, given that we are about 6 minutes over, let's just go ahead and switch right back really fast. We wanted to give you a couple of demos as part of this, but let's talk about call to action and some resources, and I'll let Jeffrey speak to this. What should we be doing next?
All right. Okay, so here's a number of links to call to action. We're proactive, we're engaging the community, we want to engage with you. So here's a link to the AI Business School and our AI initiative, Microsoft AI for Good initiative. Here's a set of resources that you can then follow up on. Again, all these will be in the slides. Give you a second to take a picture. By the way, if you're taking a picture of slides, if you haven't found Office Lens, you got to definitely install Office Lens. It's amazing. Office Lens, you take a picture and it figures out the skew and does proper things, and you can even save it and it'll OCR it for you. It's crazy good. Office Lens for your phone. All right. So the heart of this, right? Microsoft has a point of view. AI is software 2.0, a new set of challenges, a new set of issues. We are at the beginning of the beginning. Microsoft plans to lead by having a very strong point of view and engaging the community and our governments and our legislators on that point of view. We strongly believe that AI needs to be ethical and that it should help everybody and every organization achieve more. That is our talk. Thank you so much for your time.